Hello friends, today I'll discuss another one of the interesting topic of the IoT applications, that is flood monitoring system. Okay, so how can you monitor the weather, the upcoming days, any flood will happen or not? This thing I can check by using the IoT. How we can check? We can measure the temperature, pressure, and suppose if humidity and if humidity and rain, the measurement of the rain also we can check, right? If the measurement of rain is also is more, so again we can check the the sea level. Okay, so if sea level is also high, so we can the IoT application can automatically give a one signal that the flood in the upcoming days the flood will happen, right? So in our case, what are the components or what are the sensors we have used for flood monitoring system? So it is a little bit different from the environment monitoring system. In the next lecture, I will discuss about the environment monitoring system. So this is the flood monitoring system, right? So in this case, I have to check the rain, the amount of rain is that is flowing. Okay, amount of the rain and the humidity. Based on those things, we can measure the flood warning signal, right? And apart from that, the sea level we can measure. So for humidity and the rain, there are the two sensors. So by using those sensors, we can measure the rain and the rain level and the humidity level, right? And how can you measure the sea level? So we can put the ultrasonic sensor near the sea, and here if the sea level is cross the certain limit, then the some warning signal will be there. Okay, so based on this thing we can implement, right? So rain and humidity, these two sensors are available for rain and humidity detection. So in our case so in Tinkercad some inbuilt sensors are available. Apart from that, we have to go through the download and the library function. So in Tinkercad, so for understanding whether this my protocol is working fine or not, so I have used the potentiometer with respect to rain and humidity sensor. Right, so you can vary the potentiometer and you can check the what is the rain level and the humidity level, right? And this value we can monitor on the LCD as well as the serial monitor window if required. And so if the rain is high and humidity is high, then the sea level, that time only the sea level will be monitored by the ultrasonic sensor. Okay, so when I will write the program, so it will be like that. When the humidity and rain level is more, then the ultrasonic sensor will measure the sea level. Okay, and if the sea level is high, so that time only the sea level will be different. A low sea level, medium sea level, and high sea level will be displayed on the LCD screen. If the sea level is the high, then that will then the warning signal will be sent through the LED and the buzzer. Okay, and the information is also will be passed on the LED, right? So this the total phenomena what I want to do. Okay, LED and buzzer. Now I will show the Tinkercad diagram. So the diagram is little bit complex because here I have used the LCD. That's why. Okay, if you remember the LCD connection, then it is easy only. Already I have discussed various component how we have to connect the ultrasonic sensor and LCD, and with respect to ultrasonic sensor and LCD, what will be the set of instruction and program code. This I have already discussed in the previous lectures, right? So here Arduino and the two potentiometer for the humidity sensor and the rain sensor. That information will be displayed on this LCD. If the humidity is or rain is more, which is detected by which is displayed on the LCD, then the sea level will measure by the ultrasonic sensor. Okay, if sea level is high, that time the LED or buzzer will be turned on. You can connect any one. Okay, not two, both one is not required. You can connect any one. Okay, so the potentiometer, there are the three terminals. The middle one is normally connected with the analog pin of the Arduino. So two potentiometers, then two analog pins are required for connecting these two potentiometers, and the positive and negative one will be connected with the voltage and the power supply and the ground from the breadboard. The LCD connection, that these I have already discussed in the previous lecture. You can go through my lecture. And Arduino also, there are ultrasonic sensor also, there are the four pins, VCC, ground, and the trigger pin and echo pin. The trigger and echo, these two should be connected with the digital pin. And LED and buzzer, anyone you can, both or anyone you can connect to the any digital pin of the Arduino, because the one is wrong. I think it will be turned on or turn off. I think by it will be buzzer on or buzzer off. Okay, that's why these two will be analog signal. And humidity and rain sensor, these are will be the analog input. Okay, this will be act as analog, because the rain is the analog. We are collecting data from the physical world in the form of the rain and the humidity. That's why these two data will be in the analog in form, right? So now I will open the Tinkercad, and I will again show the connection. Okay, but because it is not visible here, and I will show the program code and run execute the program and how it is working. So now I am going to open the Tinkercad. So here I open the Tinkercad platform where I have designed a plant monitoring system. Okay, so you can see these two potentiometer. If there is a marker, if that is in the left side, that is the potentiometer value is minimum. If it is in the right side, the potential value is more. Potentiometer value is more. Okay, so you can see the terminal 1 and terminal 2, you can connect with the positive power supply and the ground from the Arduino. The middle one pin is connected to the analog pin. Here also the same connection. Okay, so LCD connection, that I have already discussed in the previous lecture. You have to connect the LCD with the Arduino through the digital pin only. And Arduino also, the trigger and echo pins are available along with the VCC and the ground pin. So respectively, trigger and echo will be connected to the digital pin of the Arduino, and the VCC and ground will be connected with the breadboard of the positive line and the negative line, right? And anyone you can connect, LED or the buzzer, or you can connect both. So already I have discussed in the previous lectures how to connect the LED and the buzzer. Okay, now I'll show the code here. Okay, so LCD, for writing the LCD connection, so you have to include one library. And what are the digital pins you have connected to the LCD? This digital pin I have to mention under this line. Okay, liquid crystal underscore high space LCD within bracket this LED pin. LCD pin. Buzzer, that is the digital pin I have mentioned at 2 number pin. And from the ultrasonic sensor, trigger pin and echo pin, you have to connect with the 9 and 10 that I have written. So for executing the ultrasonic sensor, you have to declare two variables, distance and the long duration. Okay, so now I will come to the void setup function. In void setup function, all of you know the LCD dot begin. You have to write for LCD to initialize the LCD, and so serial dot begin you have to write, and the pin mode you have to write whatever the pin you have discussed. So analog pin is not normally, it's not required to write the potentiometer. So buzzer pin, LED pin, trigger, echo, these the digital pins. These I have written which pin is the input configuration mode and which pin is the output configuration mode. In the trigger and echo, so one pin is I have to connect with the input echo pin, and the trigger I have to connect, because I am for sending the signal from the ultrasonic sensor to the environment for detecting any object or sea level. That's why the trigger pin is the output pin. If sea level is there or if any object is there, then that will be detected by the echo signal. That's why the echo pin is the input pin. This information I have already shared in the previous lecture. Okay, so this two analog, the anode is connected, that I am considering as a rain sensor, and this is considering as a humidity sensor, right? So the anode pin, that this is the analog rate. So we are storing the rain data in a one variable. Under the void loop function you have to write, right? So int value underscore rain analog read anode. In the same way, you can read the humidity data, and you can store the humidity data and value variable. Okay, so for that again you have to write the analog read function. Analog read, because these are the analog data, and I'm taking input from the humidity sensor and the rain sensor into the Arduino, right? This is the connection. So these two value you want to see in the serial monitor, you have to write again the serial dot println rain value and the humidity value. Okay, so based on the rain and the humidity, the some message will be displayed on the LCD screen. So if humidity there is low from the 164 and rain is low from 164 and humidity is low from the 40. So in the top line of the LCD, the dry weather, and the bottom line of the LCD will be the value of the humidity, like this way. Okay, and based on this you can put the various message, and based on this you can put the various condition. Okay, what will be the, if humidity value is some and the rain value is some, then within the one between the 165 and the 327, then this will be the dew, and the humidity is less than 60%, humidity is increasing. Okay, based on that you can write the message. And again the rain is greater than 328 and the less than 511, and humidity is greater than 101 and less than 222, because the end operation. So what is that, the first I have written the what is that, less than 164 and less than 40, but next condition is within the some limit. Okay, 165 between the 320, so some limit you have to put. Okay, if you write only the value of rain is greater than 165, so it will be up to up to from 165 to the up to the maximum range. Okay, so based on some condition you have to put, or some range you have to put. So if the rain value is within this range, the some message will be displayed, and humidity accordingly humidity message will be displayed. So 2 3 condition I have mentioned here. The last condition is that if rain is greater than 855, okay, and humidity is greater than 301, then humidity is 100%. Okay, so if humidity have the 100%, if very rain, then I have to check the sea level. If rain is heavy, then you have to check the sea level. So if this condition is there, okay, then the ultrasonic sensor function have to write under this loop. Okay, you can say already, you can also write inside this loop, or you can separately write the ultrasonic sensor code in a different loop, where you can put the same if condition. Okay, rain value is greater than 855 and the humidity value is greater than 301. Okay, so here the ultrasonic sensor, how to write the ultrasonic program, this I have already discussed. So only the distance you have to change based on your program. What will be the minimum sea level? If the distance is less than 50, then the sea level is low. If greater than 50 and less than 100, then sea level is 100 average. If the distance is greater than 100, then the warning signal will be there. Okay, so that means first I have to check the rain and humidity data, and we have to put some message on the LCD. If humidity and rain data is more, then there's some message will be displayed on the LCD, and accordingly the ultrasonic sensor will be detect. So ultrasonic, in that condition ultrasonic sensor program I have to write, and from the particular condition that the humidity is more and the rain is more. So in this particular condition I have to check the sea level by the ultrasonic sensor. 3 sea level I have to check. Okay, so for that, under the ultrasonic sensor section program, so you have to put the 3 conditions: less than 50, greater than 50, and less than 100, and greater than 100. You can change your own program based on the condition. Okay, the logic you have to make. If you know the logic, you can write the program, and the same program almost that ultrasonic sensor you can use in the various program. The LED buzzer, this you can also use in the various program. Right? So if the distance is greater than 100, you have to put turn on the buzzer. So that's why the buzzer program I have written under the distance greater than 100. This loop, under this loop I have written, and the warning signal for flood. Okay, so now I will show the execute the program. So here already the potentiometer value for both the potential values are more higher. Okay, so already the message is displaying that first it is displaying very heavy rain and humidity, and it the clear the message, and again it is displaying sea level is average now. So if you change the ultrasonic sensor, you can see warning flow for flood. Again, if you reduce in the distance, flood. Okay, average. Like this way you can change. Okay, if you move up and down, the message will be the flood signal, sea level signal will be changed. Okay, first it will display the value for humidity sensor and the rain sensor, and after that the message will be displayed for according to, if you change the ultrasonic sensor value, accordingly the message will be displayed. If you reduce the potentiometer, the respective humidity and sensor value you can check. It is not displaying, so it will display after some time. So you can also check the humidity and rain sensor value in here only. The 184 is the rain value and 471 is the humidity value. Like this, so you can also check. It is low, less, you can check. Okay, so this is about the weather, sorry, flood monitoring system. So please like, share and subscribe my channel. I think you like my video, and if you have any doubt you can message me on the comment section. Thank you.